Hi there, my name is Mr. Haralabidis, and in this video, which is actually a part of a bigger set of videos focused on the syllabus of the AP Precalculus, we will continue our explorations with a subtopic titled by graph of a function. So we all know, we can all identify a graph when we see it, but what is the graph of a function? How could we actually define such a graph? Although there's no official definition, there's no official mathematical definition, I would say that the graph of a function is the visualization on a set of axes of all pairs of input and output values that are connected under that function's rule. I know it might seem bizarre or even hard or even complicated, but that's what, at least for me, is a graph of a function. Once again, is the visualization, is what we see on a set of axes. We need to have a set of axes, the vertical and the horizontals, and the horizontal ones, on which we actually see all pairs of input and output values, all the ordered pairs, that are connected to each other under its functions formula. And this definition that I just gave could actually answer the following question. How can we draw a functions graph? Well, we would begin in step one. I would begin by knowing the functions notation. Assuming that my function is called f, I would like to know what f of x is equal to. Then, in step two, exactly because I defined the function as a visualization of pairs of input and output values, I would need to create these pairs. I would, one by one, create such pairs. Now, to do that, it could be endless in most cases, because it would need from us to create a table of values. We could actually put by ourselves the x values, let's say 0, 1, 2, 3, 4, but then following the instructions given by the functions notation, I would calculate its y value. So, assuming that I did that and I got 1, 4, 10, 6, and 0, this means that now I have the pairs I needed. I have now the pairs of input output values. What did I just define? How did I just define a graph? It's the visualization of these pairs. So all that is left from me is to go on a set of axes This is the x-axis and this is the y-axis, and actually put these pairs. So 0, 1, it could be here, 1 to 4, it could be here, 2 to 10, it could be here, 3 to 6, somewhere here, and 4, 0 would be there. Now, I did it for 5 specific points, 0, 1, 2, 3, and 4. What the calculators actually do is repeat that same process for infinitely as many points. Not just 0, 1, 2, 3, and 4, but 0, 0 0.1, 0 0.2, 0 0.3, 0 0.35, and so on. So when the calculators or when machines do that, they actually calculate everything that happens between these points. So it could have been that. And if you place all these points one next to each other, then you actually get what we know as a functions graph. It's as easy as that. Of course, we will never, not even me, and especially not you, we will never be asked to draw a random graph. We will see on later videos that we are supposed to understand when we have a linear graph, when we have a graph, a function that represents a line, when we have a quadratic graph, when we have a cubic, a third-degree graph, and a square root, a logarithm, an exponential, and pretty much these ones. So we will need to know those by heart, but in general, we need to understand, this will enhance understanding, we need to understand how a graph is actually formed. And these are the 4 easy steps. We need to have the instructions, we need to start creating these pairs, and once we have them, we just plot them one next to the other. We will work together to such examples. Draw the graph of f of x equals 2x plus 6. Now, some of you might recognize that this is actually a linear function. Linear function means that its graph would be a line. How many points do I need to define perfectly a line? I need 2 points, and I would be done. So that's exactly what I will do. Here it's the x, here it's the y. So I'm going to assign 2 x values. And based on this rule, when x is 0, y should be 2 times 0 plus 6, it's 6. When x is 1, y should be 2 times 1 plus 6, it's 8. So I'm having 0, 6, and 1, 8. I just created the pairs of input and output values I needed. So I will go to a set of axes and place these points. It's 0 and 6. Let's assume that it's this point. And then it's 1 and 8. Let's assume that it's this point as well. So we knew that that would have been a line. There it is. This is it. This is the graph of that function. And the second example, draw the graph of f of x is x squared. We do recognize that this is a quadratic. This is a quadratic. We expect it to be either in a U shape or an upside down U shape. Actually, although we should know that by heart, let's see how we could actually draw that. I will create already the set of axes, x and y. And here I will create a table of values, x and y. I will randomly assign values, and I will assign symmetrical values around 0. When x is 0, 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1 squared is still 1. Negative 2 squared is 4. So I'm gonna put these points. Here it's 0 and 0. 1 and 1 should be here. 2 and 4 should be somewhere let's say here, -1 and 1 should be here, and -2 and 4 should be here as well. Then all that it's left is for me to just connect those. Of course, in the AP Precalculus, we will also be using calculators. So it might be just a calculator exercise. But on top of everything on this video, just remember how the graph is actually created. That would be all for now. If you found this video helpful enough, you can always like it and you can always follow me and subscribe on this channel. As always, thank you for watching and we'll see ourselves hopefully in one of the following videos. Have a great day.